Finding the equation of a line. This is also part of exercise 4.2. It's only a small part of that exercise, but it's definitely something you need to know in order to do the next exercise, which is exercise 4.3. So if we are given the gradient as well as a point that lies on a particular line, then we can easily find the equation of that line, but we need those two things, or a combination of other things that we're going to learn about later. So the general formula of a linear equation or a straight line is this right here, y equals mx plus c. Now we all know now after the last tutorial that m is gradient, and that changes for every equation. M is never the same. And this c at the end here actually signifies the y-intercept, where the straight line that you're finding or have found would hit the y-axis if it's going to hit it at all. Sometimes it doesn't hit it. So this y here and this x here, they stay there and we can sub things in for them. But when we're looking for an equation, it might look something like this. Y equals 2x. See how the y and the x are there? Or it might say y equals negative 15x plus 5. I'm just making these equations up, but they're all linear equations. We have y equals something x plus or minus something. There doesn't have to be anything at the end, but sometimes there is. So these are examples of linear equations. I'll just write that there. So we're going to dive straight into an example and find an equation. Examples of linear equations. Okay. So, having learnt about that and how we get our equation, I'm going to write down the formula that we're going to use when we're finding the equation of a straight line, when we have this information. There it is right there, and I'll put it in a bubble. If you have a close look at it, hopefully you can see it. It says y minus y1 equals mx minus x1. So it's we've kind of got those x1, y1 letters from before going on. In the previous tutorial, remember we learnt that the gradient is y2 minus y1 over x2 minus x1. But because in this sort of example we've only been given 1 point, not 2, because before we had 2, we're only looking at x1 and y1. So that m there is the gradient, and this y and this x are, like what I showed you before on the previous page, they stay there. So when we're going to do an example in a second, this will change to a number, this will be a number, and so will this, but this y and this x will stay as a y and an x. Okay, so here's our example. Find the equation of the line. With gradient of 10 and that passes through the point, because we're going to be given 1 point, passes through 111. So here in this question we're trying to find an equation of a line. We have a gradient and we have 1 point, and that's all we need because we can use this rule now to find the equation of that line. So hopefully I can squeeze this onto the rest of the page. Here's my formula, y minus y1 equals mx minus x1. Now I'm going to sub it all in. This is the x value, the x value of my first point. This is the y value of my first point, right here. So that was an 11, by the way, not a 1. So 111. So let's sub it in. Remember I told you this y and this x are going to stay. Y take away y1, which is 11, equals my gradient, which is 10, because they told us that in the beginning. This x has to stay, minus x1, which is 1. This isn't quite looking like the general formula for a linear equation, but we can make it look that way. So I'm just going to take this over to the next page and write what I had out again so that we can keep working on it. So that's where we were. I've just started a fresh page because I've run out of room. Okay. So now we want to make it look, I want to write this at the top, y equals mx plus c. And I'll put that in a bubble. We want it to make it look something like that. So we basically want a y on the left hand side and everything else over on the right hand side. So I'm going to expand. I'm just trying to neaten things up a little bit. There's a few different ways you can do this. You could take the minus 11 over first. I'm going to expand the brackets, then I'll take the minus 11 over. So 10 times x is 10x. 10 times negative 1 is negative 10. And now I've got y minus 11. The last, or second last step I'm going to have to do is move that minus 11, and the opposite of minusing 11 is plusing 11. So 10x minus 10 plus 11 equals y. This is the final step now. We're going to have y equals something x plus or minus something. Y equals 10x. There isn't any other x's to simplify with. And minus 10 plus 11 is positive 1. So there's our equation right there. That wasn't so bad. The equation of the line, so remember in the beginning we were finding the equation of the line that had a gradient of 10. We have a gradient of 10. And it passes through the point 111. So let's just check if it works. Does it work? It clearly has a gradient of 10, but if it passes through the point 111, we should be able to sub 111 in and get the right answer. So 111, x is 1, y is 11. So 11 should be 10 times x, which is 10 times 1, plus 1. 10 times 1 is 1, plus 1 is 11, so we have the right answer. That is, right there, that is the equation of the line that we're looking for. Y equals 10x plus 1. We might do one more, and you should be right to finish exercise 4.2. Alright, so find the equation of the line. This is actually, it's question 2 that has these sorts of questions in it in 4.2. Sorry, not question 3. Find the equation of the line with a gradient of, we'll have a negative gradient this time, gradient of negative 2 that passes through the point 4, negative 1. So this example is identical basically to the last one we did, except for that our gradient is negative. And that would mean if we eventually graph this equation that we're finding, it would have a negative slope, descending slope, rather than an ascending slope. Alright, so we do exactly the same thing as before. So I'm bringing back that new formula from this tutorial that you've just learned. Y minus y1 equals mx minus x1. That's the formula we're using, exactly the same as before. And our point here is right there. So this is my x1, this is my y1. No need for x2s and y2s, we only have one point. So let's sub it all in, remembering that this stays and this stays. So y take away, y1 this time is a negative, so it's going to be take away negative 1. And our gradient we got told was negative 2, negative 2. The x stays, take away our x1 which is 4. So let's neaten this up like we did before. That's going to be y plus 1 equals negative 2x. A minus times a minus is a plus 8. Okay, now we want to get y on its own, remember. Our formula should look something like this, like we did in the last example. So we want to get y on the left and everything else on the right. So y equals negative 2x plus 8, which is still there. And the opposite of plusing 1 would be minusing 1 on this side. Y equals minus 2x, and positive 8 take away 1 is 7. So that should be the answer to that question. Now, like I said before, this is question 2 of 4.2, and I think that's the only part of 4.2 that asks you about trying to find the whole equation. But it is handy to know how to find it just for the future. So try the rest of the exercise and see how you go. Good luck.